Hello, my name is Kirsten Walsh, and today I'm going to be talking about the Clean Air Act. This is my environmental geology final project for the fall of 2021. As an environmental science student at CSU, I've been learning a lot about the Clean Water Act, so today I thought I would dive into the Clean Air Act because it's relevant to environmental geology. So air pollution creates the highest environmental risk to public health in the United States, and pollution is created when there is a high amount of particles and chemicals and other things in the atmosphere, and sometimes they're visible, sometimes they're not, but this pollution leads to a risk to human health and environmental health. And industrialization in the early 20th century really picked up and kicked up the air pollution in the United States. Smog became really common until the 1970s and induced high amounts of emphysema and asthma in the American population. So in the photos on the right, you can see the Manhattan sky. Well, you can barely see the Manhattan skyline from May of 1973. These are pictures that the EPA has archived from that time when the Clean Air Act first got off the ground. So what is the Clean Air Act? It is a all-encompassing federal law which regulates air emissions in the United States. It aims to protect public health by providing air quality standards, and it regulates the emissions of hazardous air pollutants by industries and private citizens, and it is run by the Environmental Protection Agency. So there were several iterations of the Clean Air Act before 1970. The first one being in 1955 was the Air Pollution Control Act, and when this was written, it wasn't actually mitigating any pollution at the time. It was just the federal government putting money into the research of air pollution in the U.S. So this led to 1963, the first writing of the Clean Air Act, and this was when more money was put towards research and monitoring pollution, as well as kind of just trying to slow pollution down a little bit. Then in 1967, we have the Air Quality Act. So this was when the monitoring of interstate pollution began, because it was apparent that pollution wasn't only affecting the places where the pollution was sourced from, and it was actually having negative impacts on the entire country and possibly the whole planet. So that is when the federal government started expanding their monitoring and started doing inspections of industries and ambient pollution studies. Then we get to 1970, where we have the Clean Air Act that we know today. It was updated and revised, and then it became an active limiting process for emissions from industrial and mobile sources. So it was no longer unfettered pollution happening. And the government decided standards which needed to be followed by every state, and enforcement of the air quality standards were put into place. So the EPA was actually founded in December of 1970 in order to enforce this new Clean Air Act, as well as the Clean Water Act. And this was done by Richard Nixon's administration. So there were 4 national standards under the Clean Air Act: the National Ambient Air Quality Standards, the State Implementation Plans, and these are the documents and regulations that are used by states and territories to maintain air quality standards. It's a standardized system so that everyone is able to maintain the same qualities. The New Source Performance Standards are federal standards that are uniform and technology-based in order to address new sources of pollution, which means that as new sources of pollution occur in the future, we are able to update technology and change how how things are done in order to address those problems. And then we have the National Emission Standards for Hazardous Air Pollutants, and HAPs are hazardous air pollutants, and they're known to increase rates of cancer and birth defects, and they might also be detrimental to reproductive health. But today, we're going to focus on the National Ambient Air Quality Standards, because these are 6 major pollutants which can harm humans and the environment. So sources of air pollution come from just a wide range of practices, such as driving cars and riding in airplanes. And then dry cleaners were high emitters of pollution for a while there, using solvents that release toxic chemicals and using solvents that create volatile organic compounds. And then pollution also comes from factories and industrial processes, as well as natural processes like dust and volcanic eruptions and forest fires. And then there's some photos on the right to illustrate those concepts, including a large dust storm that occurred in Arizona a few years ago, which led to poor air quality. So the 6 harmful pollutants that we're going to talk about, the first one is ozone. So ozone is actually also another name for smog. It's called ground level ozone. And ozone is created by the combination of nitrogen oxides and volatile organic compounds with sunlight, and those create smog. Nitrogen oxides and VOCs are emitted by vehicles and industrial power plants as well as factories. And smog can be carried by the wind, so it's not necessarily going to stay where the industry is or where large cities are. It can also impact rural populations, so that's why it's important to monitor and mitigate smog as much as possible. And it's also visually unappealing, and it makes it hard to see, which can be dangerous. So the next harmful pollutant we're going to talk about is particulate matter. So particulate matter forms from solids and liquid droplets combining in the air. And particulate matter are things that come from natural processes or things that come from chemical reactions by vehicles and, again, power plants and industrial sources. There are 2 sizes of particulate matter, and that's PM10, which are particles smaller than 10 microns, like dust, pollen, and molds, which are, caused by fires and plants and things like that. And then you have even smaller particulate matter, which is less than 2.5 microns, which comes from combustion, and then organic compounds and metals. And these aren't visible to the human eye. They can only be seen with electron microscopes, so that's why it's important to have EPA standards to regulate how many of these dangerous particulates are in the atmosphere at any time, because the larger ones irritate your lungs and things like that, but the smaller particles can actually enter a person's bloodstream. So if there's organic compounds or metals entering bloodstreams, that can be really dangerous to humans. Another harmful pollutant that we have is carbon monoxide. Now this one's less common. It's a result of burning like fires, or it can come from car emissions. It's an odorless and colorless toxic gas, and it's really unlikely that it'll occur in high levels outdoors, but it is monitored by the EPA. Indoors, it can be really deadly in high concentrations, but outdoors, it's less likely. But when carbon monoxide pollution does happen, it can have negative impacts on people's health, causing people with heart conditions to have a reduced ability to oxygenate their blood. So that is why it is considered harmful. So the next one is lead. Lead is a huge topic. It's a pollutant in the air that is monitored by the EPA, as well as, in other instances like in water. But it is monitored in the air because it can come from ore and metal processing. It also can be emitted by waste incinerating and lead acid battery manufacturing. And it can be found in high concentrations near lead smelters. And lead just has tons of negative health effects. And it can also be deposited into soil through air pollution. So it's really important to mitigate lead pollution in the air. Something interesting about lead is that the EPA was able to remove lead from American gasoline. They started in 1980, and then from that, atmospheric lead actually decreased by 98% between 1980 and 2014. And interestingly, the world was recently declared lead gasoline free because there was a stockpile of lead gasoline in Algeria, and it was the last lead gasoline that existed, and Algeria finally used up the last of it, so there's no longer lead gasoline being used in the world. So things like lead mitigation can actually save the world and the country a lot of money and damages to people's health and environmental impacts down the line, because the UN estimated that removing leaded fuel from common use prevented $2.4 trillion of spending per year because of better human health and lower crime rates, which was associated with lead toxicity. So our next pollutant is sulfur dioxide. Sulfur dioxide is emitted from industrial processes, and it is kind of an indicator of other sulfur oxides in the atmosphere. So we also monitor for other sulfur oxides, but the main one we look for is sulfur dioxide, because if that's high, then there's probably other sulfur oxides in the atmosphere. So if that can be reduced, the sulfur dioxide can be reduced, and other sulfur oxides will be limited. Sulfur dioxide pollution comes from factory and industrial emissions, and it can also be emitted from volcanoes or from vehicles like ships and trains that burn fuel with sulfur in it. It can really have negative impacts on people and children with asthma. And it also impacts the environment by creating acid rain. Nitrogen dioxide is similar to sulfur dioxide. It is also an indicator of other nitrous oxides in the atmosphere. It comes from vehicles and power plants. And short-term exposure to NO2 can cause respiratory agitation, and long-term can lead to the development of asthma and other common respiratory infections. And then nitrate particles can also create haze in the atmosphere and make it low visibility. So other important mitigation that the EPA does is of acid rain, ozone layer depletion, and regional haze. Here are some pictures of pollution from the 70s. It was said that people in Denver couldn't see mountains 35 miles away. And then here's a picture of a child playing in a really heavily polluted area of North Birmingham in the 70s. But the EPA has done a good job of removing obvious pollution and not so obvious pollution from the atmosphere in the U.S. And it's prevented a lot of deaths. But we still have some issues with atmospheric pollution, such as greenhouse gases and things like carbon dioxide in the atmosphere still increasing. Here are the sources.